got a graph, we matched it with a statement, yeah? So Luke, to be honest, this is very similar to what we've done the lesson you were here. Remember, we cut them out and we matched a graph with a statement with, remember, have you got it, the other pages? What's missing, say? That's the words, the graph. The other ones we did beforehand that I also got you to stick in. Coordinates and a table. Good, yeah. So that's what we haven't done this time, Luke. So you've got that one in front of you, all right? You didn't stick it in, but I might have another one anyway. So in fact, I have. I'll print out the one I've got for you, all right? So what's missing? So we've got a graph and words, but we can now create our own coordinates and table, all right? So we're sort of filling in the gap for each one of these, all right? And we're just going to check that you're all good with that, all right? So, first of all, can you just for Luke's benefit, can you explain why this graph went with this statement and why we labelled this centimetres and this months? Anyone want to give it a go? Slim?
Basically, it says when we planted a seed towards area from seed, the new 2 plants grow 2 centimeters each month. So it starts from 0 because a plant starts from the ground. And then each month it grew by 2, so that it went by 2 each month.
Yep, that's it, isn't it? All right, so I'm going to pick a couple of points here, which is, so Talia said, it's centimetres because this basically is how the, this is how the plant is growing, right? This is the height of the plant.
So if it goes up to every month.
Yeah. So this is the month. So we know that at the start, this is the problem. At the start, the plant is 0 centimetres high. But after 1 month, the plant has reached 2 centimetres. After 2 months, the plant has grown to 4. 3 months, the plant has grown to 6, and so on, yeah? So we can see that every...
In a way, you're just kind of like going to month into the, like, how tall the
Yeah, that's something to notice as well, yeah. You take the month and you double it. We're not quite there yet, so actually you've stepped up, but that's a good spot, all right? So, that explains it. So every month, that's why the months is this axis, all right? And the centimetres, how high it's grown, is that. Now, it's not up because the plant grows up. So something to add to your notes, guys. This is what we call, months is the independent variable. Do you want to add that to your sheet? Some vocabulary. You can do it on any of your graphs if you like. Try not to fill the space because we're going to do tables. Alright, so leave yourself enough space.
So what's within your book is not the ones that we cut
No,
out.
we've done another one. So, if
Wait, we didn't have class yesterday, did we?
no, day before. Tuesday.
Oh, yeah.
Yeah. I think it's video for you to catch up. But I'll print out the sheets in a sec. Alright. So we've got the independent variable. Now this one is called the good dependent. Have you done this in science already? Good. The dependent variable. And it's because the height depends on how long you've been growing it, yeah? So it's like we can tell that the plant will be this high after this many months. We don't say it's been this many months because the plant is that high, although you can read it that way. But it's the time passing that allows the plant to grow. All right, so that's why we have it that way round. Right. Now, what I'm just going to pick on then is we want to write down the two other forms just so we practice. We want to write some coordinates. So the first coordinate, if I write 0, 0, does that make sense?
Yeah.
The next coordinate we could pick is 1 and 2, yeah. Because remember it's x, y, so we should have, what is it, months
0 months.
and centimetres.
0 months, 0 centimeters. So that period of time, however long it does grow.
So after a month, so the next one we could do 3, 6. I've skipped one, haven't I? But does it matter?
No, it doesn't.
We could do 7, 14, and that because Luke helped us see that it was doubled, all right? But we could just say it's 1, 2, 2, 4, 3, 6, 4, 8. We pick these coordinates, yeah? Now, something that I do like to really hammer home, it helps people understand, is do we join these points with a line? At least you gave an answer to it. Both of them, but yep. Alright, so technically, what you actually physically do is when you've worked out those coordinates, you would just draw a line through them. But a line like this is not actually a line. What is it? It's all the other points. Because we do measure a plant between 1 and 2. We do it after 1 month, after 2. But does time happen in between? Will a plant magically go from 2 to 4 without going anywhere in between? No. So there is actually another point at 1.5 months, which is 3. So we could have a coordinate that would be 1.5, 3. Okay? So actually this line is not a line, it's actually an infinite number of points that represent times, like you said. Yeah, times and heights. If I draw all of them that I could possibly do, I would have a line. Because there's an infinite number of points, depending on, like, is it worth measuring a plant every second? No. But technically I could do it. So that would fill in some more points. Now, in between a second is every millisecond. Is it worth measuring a plant every, or can I even do it? No, but technically, mathematically, those do exist, all right? And I'm assuming that the plant grows at this normal rate. In reality, would a plant actually grow linearly like this? No. So this is actually a rough one. Like, it can be described like that, roughly, but plants grow. You've seen trees, they have bigger rings, smaller, when you, all right? So it might not actually be there, but the important thing is we've got our coordinates, we've taken it from the line, so each point on the line represents what's happening. So then all we have to do is go for it. So these are the coordinates, right? So that's another form of the same situation. And then we should write our table of values. Question, Luke?
I'm not trying to get too scientific because this is math class, but like wouldn't it also depend on like how the person takes care of the plants?
Yep. There's a lot to it, isn't there? This situation is that criterion D. Does it make sense? Right? We've what we call modelled the growth of a plant using a straight line. Right? Now we've simplified it to help us understand because that's where we are in our maths career. But as you get better and as you get older and you study more science and that kind of thing, and biology, and you understand that actually it won't grow perfectly straight line, will it? Right? But what we've called simplified it. But let's look at our table of values then. So we've got a table. We could draw this out. You've got squares in your book. What goes here and what goes here? Well, we don't. We could do X and Y, but we don't have X and Y. We have. Which one goes where? Good. Let's do months. I've put moths. Moths. Accidentally, I've got loads of moths in my house at home eating it, like little larvae everywhere. It's horrible. So I've got moths on the brain, not literally. Moths and centimetres. Don't write moths. I bet one of you will write moths now instead of months. And we can write our months as it's basically these numbers again, isn't it? 0 months, 0 centimetres, 1 month, 2 centimetres, 2 months, 4 months, 8, 10 months. Now there's also another limitation about talking about plant growth, which is what? How tall does a plant grow? Maybe after 5 months it doesn't grow anymore at all, so this line would have to stop. It doesn't go on forever. So maybe me writing 10 and 20, 10 months and 20 centimetres would be wrong. But that's again another criteria, limitations of it. Does it make sense?
More plants.
Depends, because if it's a tree, for years it grows tall, yeah? Until it stops.
Same like human beings, like we think like
Exactly the same thing. You know, you get to a certain height and you stop growing tall and you start growing out. Yeah?
It's like when you reach 18, you kind of get as tall as you'll be, and then when you reach like 25, you're kind of, it just is filled out.
Yeah, exactly. You start building. Your skeleton's got as big as it's going to be. Same with plants, isn't it? Flowers outside, actually within a month they're fully grown, aren't they? You know. So do you understand that the bit that we're focusing on is the fact that we've got coordinates, all right? We've got a table of values, we've got our graph, and we've got our worded statement, all right? And what you're going to do now is just complete those things for all these other ones, all right? And I will just quickly print off these for Luke.
Wait, I have to move those into my book, right?
However you feel.
My grandma's
Oh no. Right. So a couple of points. Common mistakes that get made, and I've seen it for a few people. All right. Coordinates. All right. Must be the x1 first, then the y value. All right. Must be. And that's because that's what they are. Right? If someone reads coordinates and you've done them the other way round, they read them correctly. For them, they will get the opposite coordinate than you expected. Yeah?
Yeah.
Right? So you must get them the right way. There's no kind of, oh, but you know what I mean. No, we don't. All right? Okay? It's like if I say to you, you know, write down a four-wheeled vehicle and you say motorbike. Okay? Oh, we not then. No. All right? I meant the car. So we must get the coordinates the right way around. And the way to help you with that, or to try and remember, is that, remember we said we've got the independent variable and then the dependent variable. We said the plant growth is found after a certain number of months. So what you need to do is you need to figure out the month that you want to know first. So we go along the independent axis first, make your choice, all right? And that's completely independent, all right? You make that decision yourself. There is nothing stopping you choosing any month. You can pick any month you like. What you then do is you have to go up to read the coordinate from the line. So it's dependent on what is there. You don't get to choose that value. So, for instance, let's pick one. We go along to the 3 I'm choosing 3, I want to know 3, no one's telling me 3, but now I have to read up, right? And I am being told that that is 6. So that is told me. It's dependent on the choice that I make. I don't get to make that choice. So that means I must do the 3 first, because that's the choice I make, and then the 6 is the number that I get having made that choice. Alright? So you must get those the right way. And the same way with, to be honest, with the table, as long as it's labelled, it's not really a problem. Someone else can then make their decision, but normally we have the independent on the top and dependent on the bottom. Now Alistair, because he's writing in big highlighter fat pen, and he couldn't fit it all in like this, he wrote it down that way, which again is absolutely fine, right? I have no problem with seeing you write months and centimetres. You could write it, because it looks like the coordinates a bit more then, doesn't it?
Yeah.
Absolutely fine. I have no problem with that. So I'm not picking up Alistair for that. It's just he only did it because he had to, because he write it. Right? But that's absolutely fine. You're allowed to do it that way if that helps. So have you got all those done and dusted now? Did anyone know they made the mistake of getting coordinates the wrong way around at all? Yeah? Sorted now then? To be honest, it's good to make a mistake, because then you learn from the mistake. If you never make a mistake and you then do one time, you won't know that you've done it. Alright? So it's not bad to make those mistakes. Alright, so I've now said to you, the next thing is, which book is that? Longer. You have just done in the textbook those ones, right? Yeah. So I printed them out for you so you could stick them all together. It makes it a bit easier. But what you are going to do now, okay, is for each of those tables, represent the pattern as a set of coordinates. Now how to do that, right? Like we've just been doing. Alright? So, let me
Oh, wait.
maybe I can do the first one with you. Alright, let's look at this first one. Represent the pattern as a set of coordinates. So here's the table. Now actually, they've done their table the same way that Alistair did his. Right? So he's already ahead of the game. Right? And they've made that nice and easy. So if I were to represent this table as a set of coordinates, the first coordinate would be 0, 9. With brackets, with a comma, please. Alright? I only say that because my M2 is that we did coordinates, and then I said to them, write coordinates from this, and they just, it was just big numbers, no commas, no brackets, nothing. What's the next coordinate? 1, 11. 2, 13. 3, 50. Okay? Then it says, represent the pattern as a graph. I have to draw a graph. So, what you're going to do then is you'll know about square paper, because you have square paper hopefully in your book. Alright? I might have some square paper if you haven't got square paper. Now what we do when we draw a graph is we don't just plonk a cross in the middle of our page. We have to fit these numbers onto it. So I should think about that. So what I do is I actually look at what is the maximum for the y value, alright? And I don't draw a line, I look at my space and I go, right, I'm going to start here and I'm going to put something like, I might actually write 16. I won't necessarily put the 16, I might say here's 16. And then I go, right, 16, 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. And I'm like, oh, that fits. I'm good to go. Alright, so once it fits and I'm good to go, what can I do? Draw my line. Yeah, so I go from 16 down to the dot that, sorry about my dotted line, it shouldn't be dotted. Question, Luke?
Is this basically like the last one? So if we start on 0, we start on 0 and 9, is it 0 and 1?
Yes.
Okay, because I was confused, because I thought we were using the same example.
No, well, no, I'm using this table. I'm doing this one with you. Yeah? Or for you at the moment. Right. Oh, we are using this one. Yeah. So I'm just drawing the graph from these coordinates. So the thing is, I know, now the mistake people do is they start with 0 and count up and then realise it doesn't fit. So I always start and count down. Makes sense, right? And then normally the x values are a bit smaller. So I then start my 0 and go, I only need to get to 3. So I can actually spread it out by 1. I'm going to do 1, 2, 3. I might even put 4. And that fits that nicely. Now there's one thing here, guys, I'm going to say. Do you notice that how, even though I'm on a computer screen and a tablet, my lines still go on the lines of the squares? Not in the middle, not diagonally. They're nice and sharp pencil lines, not a big fat highlighter line. Yeah? So get your pencil, Alistair. Not a pen. You'll notice I can delete mine very easily. Pencils. Get your pencils out. Okay? Once I've got my line drawn, I can plot my coordinates. So I can do 0 up to 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to put across there. Then 1 and 11. So I'm going to go 1, go up there, 9, 10, 11. I'm putting in an 11. That's an 11 because that's a 10. Alright. Then I notice, oh, it's just going up 2 every time. So actually I can go up 3 squares is 1, up 3 squares, I've got a shortcut, yeah? And those are my points, my coordinates. What do I do then? Draw the line, because the line represents all the other points, yeah, the stuff in between. Right? Now in this case, there is no, it's not time or anything, it's just x and y. But then it says, represent the pattern as a graph with axes labelled correctly. So we should put our numbers in and we should have y and x on the other. But then it says, describe a situation that could represent the linear pattern. So, over to you. Something that starts at 9, and every 1 it goes up, this one goes up by 2. Would you think of something? This is the difficult bit. Feel free to refer back to the other examples and just borrow one. So, for instance, the easiest one type of thing is, okay, Mr. Potts charges $9 for turning up to a lesson, and then $2 for every minute. Does that make sense? Yeah. So just for turning up, I get $9. Every minute after that, I get another $2. So there's an example.
So if class lasts for 15 minutes, you get $100.
There we go. All right. And I think it's Luke's turn to pay today.